Well, thanks for staying to the bitter end. Hopefully not too bitter end, but thanks for staying to the end. I'm going to talk a little bit today about having some fun with armies of low-power devices that you can coordinate, and you can do attacks from a distance using Xbee and or ZigBee mesh networking. And a little bit about my talk today. All right, so this is me, Phil Polstra. I teach at a university. I'll tell you a little bit more about that in a bit. But I was asked to remind you to please complete the feedback forms. All right, so what is this talk about anyway? I'm going to talk a little bit about hacking and forensics with these small, low-power devices. Low power is good because it means you can battery operate these things. I'm going to talk about an ARM-based Beagleboard and Beaglebone that's running a full suite of security and forensics tools. A little bit about porting tools to a new platform. You have the slides on your DVDs. So I'm just going to very quickly go over that and move on to the mesh networking part. And that's going to be the focus of this talk. So who am I? I profess for a living. I'm a professor and hacker in residence at a medium-sized university in Dubuque, Iowa. I've been programming since I was 8 years old. I really upset my parents because my brother and I cleaned out our savings accounts and we went and bought a TI-99 4A computer for a princely sum, I think, of $450, which was a lot of money back then. I've been hacking hardware since I was about age 12, and I've also been known to fly and build aircraft and do other things. All right, so, what am I going to talk about? What's our roadmap here? I'm going to talk about choosing a platform, then deciding on a base OS, how do you build up a system from that, a little bit about the porting process. There's different options there. Some of it's easy, some of it's not. Show you a little bit of what a single device running the deck, which is what I call this distribution, can do. And then we'll talk a little bit about what can you do in a coordinated network environment and some future directions. Okay, so choosing a platform. My goals, I wanted something small, something that I could stash pretty easily. I wanted something low power so that I could battery power it for a long time. I wanted something affordable, right? I wanted something mature, not something that just came out last week that you're going to have a lot of support issues with. Something with networking built in, some good USB support. Some of you who know me know that I like to do a lot of stuff with USB. I've been doing a lot with that in the last couple years. And something with some convenient inputs and outputs. And the winning platform, as you may have guessed if you saw it on the table, is the BeagleBoard. Right? So I chose the BeagleBoard-xM as my platform. It's 3 1/4 inches square, so it's pretty small, less than 10 watts, very low power. You can buy it. I did a little research and I found a distributor here in the Netherlands for 133 euros. Or if you're ever taking a trip to the US, things tend to be a little cheaper there because of taxes and things like that. So it's $149 US, which is like 110 euros. So you could save a little bit money if you're ever over in the US. The BeagleBoard-xM is based on the Cortex A8 processor. It has 100 megabit Ethernet built in, 4 high-speed USB ports, has USB on the go, has DVI-D and S-video outputs. It also has LCD outputs, which is what I have in my little lunchbox over there. Serial ports, webcam, audio, micro SD, a lot of good stuff. Right? Looks kind of like this. It's a nice little red board. It's meant to be a desktop replacement, and it's a legitimate desktop replacement. My BeagleBoard, I have running the deck. It sits on my desk in my office, usually hooked up to an Alpha wireless card with a nice Wi-Fi cannon. that's got a 6 kilometer range on it. So I actually, a side note, I often get my internet from a restaurant half a kilometer down the road instead of getting it from the university because they don't filter things, and I actually get better reception because my building is like a big black hole for Wi-Fi. So, and I know at least one of you is going to ask, some of you already asked, even before I started here, why didn't you use the Raspberry Pi? Well, here's why not. Number one, it's not as powerful. It does not have as powerful of a CPU, right? Doesn't run Ubuntu, right? It's based on an older ARM architecture, ARM-6. Canonical doesn't support it. It's not truly open. It's based on a Broadcom chipset, and if you want to know all about it, you get to sign an NDA, and they don't really want to tell you about it. Not really as mature, hasn't been around as long. In the cost savings, when you're looking at a full system, is pretty slight. People say, well, you can get $35, but like for me in the US, it's going to cost me over $50 to actually get a Raspberry Pi, and it's still not really available. I can't say, hey, I want 100 and get them, right? Those are some of the reasons why I went with the BeagleBoard instead. So in terms of selecting a base OS, the Beagle devices come with Angstrom, which is an embedded Linux. It's not bad. It's optimized for the hardware, has a nice package management, but for our purposes, pretty poor repository support. If you're doing security stuff, you want Ubuntu, right? All those packages are in the repositories for Ubuntu, and I wanted to make my life simple. I wanted to compile as little as possible from source code. So I chose Ubuntu. As you probably know, Backtrack's based on it. It's pretty popular, good support, and all that. So in terms of the device, it comes with a micro SD card that has Angstrom on it. I like to upgrade those to either 8 gigabytes or 16 gigabytes. You could go larger, I suppose. You need at least an 8 gigabyte because my file image is over 6 gigabytes. All right. Why is it so large? Here's what I did. I basically went through Backtrack, and I went through every single package, and I said, do I like this package? Do I think anyone ever really uses this package, or is it just there to fluff up the, hey, look at all of our tools numbers, right? And if I thought anyone might use it, I ported it. And that's why, I don't know what the exact package count is, but if I thought it was useful, it's in there. If I didn't include it and you actually use it, let me know. Maybe it could be in there. So you have two options when you're starting out and you're trying to run Ubuntu on one of these devices. You can either go to Canonical and get one of their official images, or there's a guy named Robert Nelson, and Mr. Nelson has some demo images. I used his stuff. His stuff is tweaked for the platform. It's very well supported. He's very responsive. He releases new stuff like every month instead of every 6 months. So a lot of good reasons to use his stuff. Here's a link. If you go to eLinux and you look at BeagleBoard Ubuntu, you'll find all these instructions on how to do this stuff. All right. So the easy part, I got lucky in a sense in that about 80% of the tools that I wanted were already in the repository. So it was just an easy apt-get install, done. All right. Of those that weren't in the repository, about half had a Debian package, which, okay, I had to make sure that certain things were installed, but it wasn't too much drama. And then the last 10% was, okay, now I'm getting the source code and I'm compiling it. All right. So it took a little while. This is a project that on the base operating system, I worked on this for about a year. Just a week short of a year, actually. So 51 weeks doing this. And for the most part, if it's based on some scripting language like Ruby or Python or Perl, it usually just worked. If it was based on a compiled language, sometimes you might have to get some libraries and things like that. It was a little bit more involved. Okay, so for that 10%, you have some choices, and one basic choice is native compile or cross compile. So native compile is pretty straightforward. It's possibly a little slower on a 1 gigahertz ARM chip. Cross compile, you can take your nice multi-core desktop and build stuff there and move it on over, right? So if you want to do the native compile, it's pretty simple actually. All you need to do is just sudo apt-get install build essential. And I will point out that build essential, it's build essential, not build essentials, plural. I don't know why, but that might trip you up. Something to keep in mind, if you're using the BeagleBoard platform, the BeagleBoard uses the USB chips to do the Ethernet. So every time you boot it, it's going to have a different MAC address. So if you're using DHCP and you reboot the machine, don't be surprised if you get a different address, different IP address. So just something to keep in mind if you're working with that platform. All right. Real quickly, here is one way, most straightforward way. If you want to cross compile, you download a toolchain, and here's a link here. And again, all these slides are on the DVD. And if you have any questions, just email me or contact me on Twitter. It's fine. You untar it, set up your build environment, download whatever source code you're going to do, and then you do the standard configure, make, install. The only real difference is that when you do the configure, there's this extra command here. There's this host equals, and you have to say, hey, I don't really want to build it for my machine, which is running some Intel or AMD chip. I want to run it for this. And you might give it a prefix to say, please put some stuff over here instead of the normal place. And that's about all you really have to do. That's the only real change. Once you've gotten the tool chain downloaded, you just add this extra flag to the configure command, make, install, done. And then you have to copy your binaries over, all right? There's some potential for problems with certain apps if there's a mismatch between the kernel version on your build machine and on the target machine. I haven't really run into that, but there is potential for that to be there. Another option, if you like to use Eclipse, you can install these things in Eclipse. I'm not going to go into this in detail, but basically you can use Eclipse to build the stuff. If you have a makefile, you can import that into Eclipse, or you might not want to do that because then Eclipse doesn't work as well with it. But in the slides, it'll tell you how to go through that steps. All right. And then the third option is the super fancy way. It's basically option 2, but you add remote debugging. And the nice thing about remote debugging is that you can copy your binaries automatically without having to S-copy them or something like that. So that's a convenient thing. All right. And there's a few little gotchas. You have to make sure you have SSH and GDB server installed. And one of the biggest gotchas, you got to remember to create this GDB init file. If you don't do it, like, hey, it's not working. So if you go this route, make sure you do that. All right. Okay. A little bit about building hardware. I've built a couple of things. I've adapted some Xbee adapters so that you can connect these little Xbee radios to your devices. Also built some simple power supplies, which you guys saw. The simplest one is this guy here. It's 2 9-volt battery clips, a 7805 voltage regulator, a smoothing capacitor, and a 2.1 by 5.5 millimeter barrel plug. All right. And you just solder that all together. I have one device or one power supply that's got a binder clip heatsink, and I got another one which has 3 pennies. Both of them work fine. The idea of the 2 9-volt batteries is that the 9-volt batteries, you can put one in and hot swap another one if it starts to die. Or you can run 2 in parallel. Either option works. Right? Looking at what's possible with a single device running the deck. Here's my first demo. You can guess about what the time frame was when I did this first demo, if you recognize the DEF CON 20 CD. And here's my little keyboard. Here's that Wi-Fi cannon I was telling you about. And I did the kind of standard script kiddie thing where I'm like, oh, okay, let's do a little nmap on the device and see what's out there. And when we do that, we notice, hopefully it's kind of visible. We see, oh, port 445, that's our old friend, right? We all love port 445 because what's on port 445? What's everyone's favorite exploit? SMB. Yeah, what's the number? Who remembers the number? MS 08067, right? So it's like the most popular attendee at every conference, right? It's at every conference. It's like someone said once, it's the Chris John Riley of every conference. He's always there. So is MS 08067. But all right, so as I said before, each of these devices has Metasploit. So I ran up Metasploit over here and did the standard stuff. Said use SMB MS0867, set my host, set my payload to interpreter, and bam, exploit done. And here I have a shell. And you can see this one is a Windows XP box. Now, in terms of demos, I have, if we have time, I'm going to show you some live stuff. But I also have kind of learned over time that live demos are usually a bad idea in a talk because the demo gods always just plot against you and things suddenly don't work. But in another example, things that are possible, again, it's a 6 gigabyte image. It's got a lot of stuff in it. So it's got all the standard things. It's like, let's do a little Wi-Fi cracking. All right, so run up arrow dump. And here's my network at my office, which is a lot less busy than the network around here. Right, it's just a few access points around here. And ran air crack, and sure enough, wise men think alike and choose what? Password 1. So password 1 was the password for this WPA2 network. Okay. Other things you can do, John, Hydra, all those things, they work. Oh, by the way, I have Armitage on there too, not just Metasploit. So if you like Armitage, it's there. So I ran Hydra against one of my routers and cracked my password, which wasn't a very good one. It was password, but and all that stuff works just fine. And of course, a lot of people lately, we've given some attention to WPS cracking with Reaver. When it was discovered that that whole protocol is kind of vulnerable. Some of you probably know this, but a lot of the routers, if you go into that router and you uncheck the box for WPS enable, half the time it's still on, right? So one of the things I did in a recent security class I was teaching is I actually gave them a lab, and I said, for this lab, I want you to use Reaver not to crack the Wi-Fi, but just to verify that your router has actually got it disabled. So it shouldn't be responding, things like that. But so it works pretty well. Here you can see I successfully cracked my password. Or technically I cracked the WPS pin. Right? Other things that you can do with a single device. I call this pwning Windows 7 like a Mac. Not like a boss, like a Mac, all right? And why would I say that? Well, beginning of last year, remember there was a big exploit, and then what happened? All these Macs were pwned, what, like 700,000, at least the ones that they would admit to, right? Got pwned from this Java problem. And what did some of us do? We were like, oh, you know, you Mac people, you think you're so invulnerable, right? Which is not really the appropriate response. But hey, look, I wonder if, do you think Windows 7 had the same problem? Well, yeah, it did. So here I'm loading up that Java vulnerability, and I browse on over. You know, I set the payload, all that standard Metasploit stuff, and browse on over, and sure enough, here we are. And sure enough, it's Windows 7. So here I had a Windows 7 box, you know, pwned in 15 seconds, just like it was a Mac. So. Also, after DEF CON last summer, I added some additional things that came out on Backtrack 5R3. And one of them was this Fern Wi-Fi cracking tool. I don't know if you guys are familiar with it, but it's what I call a click kitty. That's a trademark term, right? Me and Aaron Finnick trademarked that term. But, you know, click kitty is like, there's the script kitty who can take a script and modify it and download it. And there's a click kitty that all they can do is click on a GUI, right? And literally, Fern is a click kitty tool, all right? So you just tell it, hey, here's my Wi-Fi adapter. All right, here's the networks that are out there. Why don't you go attack this one? So I attacked one of my routers, and here it's successfully saying, yep, here's the password that I got. Okay. All right, so let's talk about 802.15.4 or Xbee networking. We'll talk about some of the basics, some of the hardware that's involved. We'll talk about the really simple case where you have two devices and you just want to talk. We'll talk about the slightly harder case where you have multiple devices and you want to talk to them one at a time. Then we'll talk about a little bit harder yet where you have multiple adapters and you want to talk to them all at once. And then we'll talk about the really hard stuff where you set up a mesh network. All right, so 802.15.4 basics, typically used in nice embedded low power systems. You've got two variants. You've got the regular stuff that's, you know, nominally 30 meters or so distance. And then you have the pro versions, which will go up to 1.6 kilometers, about a mile. There are two modes of operation on these devices. There's what we call AT mode, uses standard AT modem commands, and the API mode, right? Low speed, 256K or 250K, which is more than adequate for the kind of stuff we're trying to do. Supports multiple network topologies. You can do peer-to-peer, you can do star networks, mesh networks, etc. Right? One of the things, if you get into this and you go to Digi's website, you know, they're the primary manufacturer of Xbee devices, you'll just see all kinds of Xbees out there, right? So it can be a little bit confusing. You know, here's a chart from their website. You want to make sure that you get the same series devices, right? Which usually means Series 1 or Series 2, right? And I'll talk a little bit more about where you would use one over the other in a bit. Other things you should know, that the Series 1, Series 2 are pin compatible, but you can't mix and match. You have to have all Series 1 or all Series 2. Right? You can't just, well, some of them are this and some of them are that. You can mix and match on the regular and the pro. So I've got 4 adapters running over here. Some of them are pro, some of them are just regular. They all work together, right? Different antenna options, etc. Now, one thing you should be aware of, you're going to need an adapter in order to use these devices because they have 2 millimeter spacing instead of most devices have 0.1 inch spacing or 2.54 millimeter spacing. So you're going to have to get some sort of breakout board. When it comes to breakout boards, you have two basic choices. You can either do a UART or serial adapter or a USB adapter. The UART adapters is what you see on the BeagleBones over there. Well, actually, one of them, yeah, they're all UART adapters on the BeagleBones. It only takes 4 wires. You can wire it directly to the BeagleBone, and it's pretty easy. Doesn't take up the only USB port. So you probably want to go that way. Here are a couple of adapters that I bought from Adafruit. They're about $10, so they're pretty cheap. Slightly more expensive are the USB adapters. They can be helpful for initial setup. You need to connect these devices to your laptop and run some software to set them up initially. And it's easier. You just plug it in. Right? So I pretty much recommend if you have a BeagleBoard, use the USB. If you have a BeagleBone, use the UART so that you don't take up the serial port. And it's not really that hard. The BeagleBoard is a little bit harder to connect to on the serial because it uses 1.8 volt logic instead of 3.3 volt logic. So yeah, you have to configure these things. Digi provides a software. It's XCTU. Unfortunately, it only runs on Windows, but it runs just fine in a VirtualBox. If you're totally Mr. Open Source and you're like, I am not going to run a VirtualBox and run this Windows product, there is a company, Multisenso, that's released this product, Network Manager Iron. They have different versions, and the Iron version is free, and it runs on Linux and Mac, and it'll do pretty much the same stuff. All right. So how do you configure these things anyway? You take your adapter, you put it on a USB adapter like this one I got here, you plug it in, you select a USB port, set the baud rate on it. Default is going to be 9600 baud, and you can change that. And then you want to make sure you have the proper function set, especially if you use a Series 2 adapter, so that it works correctly. You set up what's called a channel ID and a PAN ID. You can select whatever you want. 1337 could be a good choice. Maybe it would be a little bit too obvious what you're doing with it. I don't know. And just make sure you choose the same channel and PAN ID for all of your devices. Now, in most cases, unless it's a manufacturer that's using Xbee networks in their company, they're probably not going to conflict with you. So, you might want to do a little bit of research on your target company and make sure that they're not running Xbee networks, because if they are, hopefully they're not also on the default channels. All right, so just do a little research there. And when you take these out of the box, they operate in what we call transparent mode. It's essentially a wireless serial port, and you set a destination low and a destination high. Typically, you'll set the destination high to 0, and the destination low is a 16-bit address, and you set it to whatever. In my case, for all of my drones, I set the destination low to 0. And then I set the my address to 0 for my adapter that I'm using here to command and control, and then the others to whatever address is appropriate. And then you just click Write and Store, and you're done. You repeat that process. If you're just configuring 2 modems to talk to each other, they'll start talking to each other, and it's really simple. Right? How do you wire them to the Beagles? The USB stuff is easy. You just plug it in. The UART's slightly more complicated, but there's only 4 wires to connect: ground, power, transmit, receive. Other thing that you need to do is you need to make sure you set up the multiplexer on the BeagleBone to properly use those pins. all right, and say, okay, I want to use these pins like this. And here's how you do that. You can consult the Beagle documentation, but you need to set up the 3.3 volt and the ground, and those are the first 2 pins. It goes 1, 2, it's a double row, and then 3, 4. So actually, both 1 and 2 are ground, both 3 and 4 are 3.3. So if you really don't like pin 3, you could use pin 4, or you could use both. Doesn't matter. And then you want to connect pin 21 and pin 22 to transmit and receive. All right. And then in terms of configuring the BeagleBone, all you have to do is echo 1 to this place, and then echo 21 to this place. All right. And then you can test a connection by going to dev TTY O, not 0, O 2. All right, so be careful about that. You might be like, what do you mean I didn't find the device? It's an O, it's not a 0. All right. Oops. Okay. You could do the UART interface to the BeagleBoard. Again, you have 4 USBs, so why bother? And it's 1.8 volt logic. If you want to do it, you don't like yourself much, and you like to spend a lot of extra time, go for it. You can go look in the documentation on that. All right, so here's the simplest case. You have 2 adapters. They're both operating in this transparent mode. You set up the addresses, as I said, and then you just need to set up TTY, or terminal, on your drone. It's pretty simple. You can run interactive programs this way, and you can go out of range. If you log in, you go out of range, you come back, and you're still logged in. It's still been off working. It doesn't care that you're not in range. It's kind of nice. So those are some advantages of doing that. The other thing is you don't have to program it. Right? You don't have to do anything other than set up TTY. Other things you can do, the slightly harder case, I can use that same transparent mode, and every drone thinks that he doesn't care about the other drones, right? All he cares about is I'm always talking to node 0. I'm always talking to that guy. That's what my destination is. So you set up TTY in all your drones, and then what do? Again, there's no programming required to go this way. You run up your terminal program like Minicom, and then you have to put the device into a command mode. And the way you do that is you hit plus 3 times. You don't hit enter. You wait, and a second or so later, you'll see it comes up and it says OK. You give it a command, ATDL. Set the destination low address to 2 for drone 2. ATWR, write it. Don't forget to write it, otherwise it's not going to work so well for you. And ATCN, please exit this command mode. Right? So here's an example. I hope that you can see. Here's what I did. I logged into a system and I just ran a uname A, and you can see it says it's drone 1 is the machine name. And I just ran a simple command. I said, what did I run? nmap. Yeah, I just ran nmap on its local address or a remote address. And then what you don't really see here, you just see OK. You didn't see that I typed in plus, 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 waited, and entered all those commands because they weren't echoed back. And then I ran another command here, and notice that when I ran a uname -a, it said that one was drone 3. Right? So it's pretty simple. You don't have to program anything. But it can be a little cumbersome in terms of switching back and forth, and it's not lending itself well to scripting, but it does lend itself well to interactive programs. Right? Slightly harder case. What if I want to talk to multiple drones at once? I don't want to do this one at a time thing. Right? Well, now I need to use API mode. API mode has some advantages. It's faster. and it's more robust, right? I will give you this little hint. If you start setting this stuff up and you're trying to figure out why it is, the little blue receive light keeps coming on your device, but nothing's showing up, you might be like me, and I'm like thinking, well, surely it's an error in my Python script. I know, who would have thought that? But, I'm not awesome at Python. So what it was is I forgot that one of the devices was still in transparent mode and the other device was in API mode. So it was sending stuff and the receive light was coming on, but it said, oh, that's bad stuff. It's not a packet. It's not well formed, and it dropped it. It took me an hour or so to figure out that I'd messed that up. But so in terms of configuring it, if you had a Series 1, again, 802.15.4 function set. For Series 2 is actual mesh networking. Technically, the Series 1 stuff is point-to-multipoint. The nice thing about it is all the software is the same. All you have to do is pull out a Series 1 modem, plop in Series 2 modems, make sure you set them up correctly, and it all works just fine. But with the Series 2, you can set up a device as a router, so it will relay traffic for you and all that good stuff. There's multiple ways that you could talk to these devices. There's a Java module. There's a Python module, which is what I used. And you could also just send raw TTY commands, which I wouldn't recommend. I mean, someone else already did the work in developing a library, so you might as well use it. Right. And this is what I would recommend if you have 3 or more devices. If you just have the 2 devices, you can do the simple stuff. This way is a little bit more robust. All right. As I said, it's really a point-to-multipoint. So someone might say, but why is your title Mesh Stalkings? Well, point-to-multipoint doesn't sound as sexy, does it? And you can, again, drop in Series 2 adapters and do mesh networking. So every drone, they don't care about the other drones still. It looks like a peer-to-peer to them. And the API mode gives you better performance and all that. One possibility, what I did, using Python, every drone on startup runs a nice simple Python script, and it waits for commands, and it has the ability to send announcements. So it receives a command, it runs the command, it returns the results, and it also has the ability, you can just run a script, says, hey, please send an announcement back. That way, let's say I've got a script, I might write a Python script that is going to run some sort of cracking utility, and then when it gets a result, it'll announce back immediately to the command console and say, hey, hello, I did this, I cracked this. And that also allows me to do things like, what if I go out of range with my command console, right? Maybe I go to dinner and come back. Depending on your setup, you could just hide your command console in a bush somewhere, or maybe it's in your Buzz Lightyear lunchbox, I don't know. And so you come back and you could set it easily to periodically announce until it's acknowledged, until you acknowledge that announcement, all right? It's good. You can't do interactive programs like you can the other way, but it does lend itself to scripting. I probably could do some interactive shells. It's not something I've done yet, but it's kind of fun. All right, so here's just a simple example. I have 2 drones running in API mode. Don't worry, I know this is kind of small, but basically I have this command window, and as soon as it hears from a drone, it'll pop open a window, and it will have all the information, all the responses and announcements from those drones. Right? So it's a pretty simple system that I wrote. You can enter a command, and it says, like here, it says enter a command for 1. If I start a command with a colon and a number, it says, oh, you want to switch to another drone. So I said, actually, I want to talk to drone 3, and I just, I'll just tail a log just to have something output. And then you can see my typo here. And then I ran an nmap command, and then I switched back to 1, and I ran an nmap command on 1. And here's the output from one of the drones. And here's the output from the other one. Right. Now, one thing that you might run into is buffering. You know, sometimes it'll save up those commands. You have to make a choice. Do you want to just keep flushing those buffers and sending every single line as it comes? Well, that's kind of a performance bottleneck. Or, you know, you're like, hey, I only got half my results. Well, just send in another command. Just give it an ls or something. And okay, now it bumped the rest of it out of the buffer and off you go. So now, if you really want to do the true mesh networking, you can certainly do that. All you really need to do is substitute Series 1 adapters for Series 2 adapters. They're really not all that much more expensive. It's just slightly harder to configure them. And it can negatively impact your battery life. In particular, if you say this device is a router, it's assumed that that device is on all the time. If it's an end device, you can let it go to sleep. And there are different sleep modes, and one of the more common ones that I'm going to implement here, I actually haven't quite configured these to do this yet, but I'll do this as soon as I get home. It will do something, and after some inactivity, it'll go to sleep for 16 seconds by default. And every 16 seconds, it wakes up for a tenth of a second, says, is anyone trying to wake me up? No, goes back to sleep. Right? You can't do that if you said, I'm a router. If you're a router, it's expected that you're always available. So what do you do for the device that you configured as a router? You better put a bigger battery on it. Right? Or, you know, if you got lucky, you're doing a pen test, and you got physical access, and they're using power over Ethernet, or something like that. Okay, set that up as a router. Go ahead and do it. But again, the scripts don't change. All that changes is setting up the little Xbee modems themselves. Right? All right. So simplest case, you only have one drone, and it's really a peer-to-peer. You can either do the Python scripting method or the interactive method. Why would you do that? You know, some people say, well, why wouldn't you just get your Wi-Fi cannon out and hack them from afar? Well, what if they don't have wireless? What if they only have wired networking? Then I really need to attach to that network. Even if they do have wireless, I'm going to look a little suspicious sitting outside their building all the time in my car. Especially if I got this huge Wi-Fi cannon, and, you know, unless I have darkly tinted windows, and, you know, there are different laws about things like that too. The other thing is your drone runs all the time. So you can go get dinner, come back. You can run it from up to a mile away. Go down the street. It's not so conspicuous, right? I'm down the street at a hotel, sitting by the pool with my Buzz Lightyear lunchbox, hacking away. All right. So other things, you probably know this, if you're doing a Wi-Fi attack, you know, sniffing, you can sniff from the parking lot just fine, and that works. If you're trying to actively do like a man-in-the-middle attack or something like that, it's a little bit harder if you're not in the building and not really close. And this allows you to get close for more successful Wi-Fi attacks. Again, each of these devices is running a full version of the deck, so there's lots of possibilities. You can send out those updates. Hey, I cracked the Wi-Fi, now let's go do something else. So if you have multiple drones, you just have a master that monitors the status of all the other drones. You can do an interactive shell into each drone, or you can do the scripting option. Right? And again, a lot of possibilities. And the nice thing about it is since you have this full distro, you can easily retask things, right? You can retask things, and if something goes down, you can redo it, right? Just a little bit about some future directions. You know, the deck platform was released in September in London at 44Con, and I've added some modules. This is the first that anyone's seen this mesh deck module, but I'm looking at adding more packages. You know, if I see a package that I think anyone would want to use, I'll add it. I might do some optimization for the BeagleBoard, looking at some other output devices, possibly associating with another penetration test distro, maybe port to another platform, probably not the Raspberry Pi, sorry. At least not right now. Maybe that would change in the future. But something I'm really excited about is there's a new BeagleBoard, or I'm sorry, BeagleBone that's coming out next month, right? And I don't know what they were officially going to call it, the next gen BeagleBone. A lot of people have been calling it the BeagleBone Black Edition. And this is a teaser picture from the BeagleBoard website. I actually have a prototype of one of these devices. I didn't bring it because I didn't want to get myself in trouble and have someone start tweeting pictures of it everywhere. I'll just say this, it's very nice. It's even more powerful than the BeagleBone. It has twice the RAM. It has HDMI output, some other nice features, and they are going to release it for less. They haven't said exactly how much less it's going to be, but they said it would be less. You know, so a lot of people call it BeagleBone Black. Other people just call it the Raspberry Pi killer. You know, choose whichever you like. Other things that I'm working on, exploiting the USB on the go functionality. Some of you may have done some stuff with USB HID devices using AVR chips. And you know, that's good and it's useful. You know, you do a little social engineering, give somebody a device that looks like a thumb drive. And you can do that, but you know, this is a little bit taking that to the next level. You know, let's say you're walking through a facility and someone's foolishly left their workstation unlocked, and you've got, you know, BeagleBone, so you have a 700 megahertz ARM processor that you can just jack into their system and potentially put in a whole bunch of commands with a lot of logic, and you know, you're not operating with a 20 megahertz AVR chip, 8-bit AVR chip. So a little bit more flexibility there, something that I'm working on. Also working on making the thing fly, literally. Looking at embedding this stuff into a flying wing platform that is capable of vertical takeoffs and landings. The idea is basically you fly it, vertically land it on the roof, and you know, it could be a router, it could be just a regular drone, it could be whatever you want it to be. And you know, might embed some nice high gain antennas and a couple of alphas in there. So there are a lot of possibilities there. Also looking at installing things like proximity sensors. So if someone notices your device on their roof and they start approaching it, the device will pop in the air and alert you, say, hey, I'm hovering 30 feet in the air, please fly me home. Because those devices are expensive and you don't want to lose them. Besides, I mean, well, there's a toy. Who wants to lose their toys? So those are some of the things that I'm working on. Here's some of the stuff that I used. I will go to questions. And again, if you haven't already done so, please do the feedback. You know, they really appreciate that. I appreciate that. It helps everyone to know how you liked it. So we're right at about 50 minutes. I'll tell you what, I'll open up for questions, and then I'll be around for a little bit. If anybody wants to, I can try to show you like a live demo and show you how to set this stuff up. But before I do that, any questions, anyone? Everyone just wants to go home, or I was so complete, right? It was just, all right, so let me just show you real quick. So here is my simple Python script, right? And I'm using this Python Xbee module, and I find a couple classes, and I have like a basic mesh deck server class for your command console, and it has the ability to send a command out, and it starts a service where it just waits for responses and communications from drones. And it has a little logic. It says, you know, are you a drone that I used to know? If not, I better add you to my list and start a new window. And then there's the mesh deck client that sits in a loop, waits for things, and there's also the ability to send an announcement by running a command line script. So if you look here in the usage, you know, you can just run it as a server, or the default, that's the default, or you can run it as a drone, or you can say, hey, please send an announcement. Again, it lends itself pretty well to scripting. So let me go ahead and run this real quick. Oh, by the way, I forgot to mention, it's in the slides, but in terms of where do you get this stuff, there's a link to the website, my website, where you can download the script. In the script, it's compressed, so I think it's only like 4 gigabytes, not 6. So it still might take you a little while to download it. And there's a script that you can run in there. There's instructions in there. You just run the script. It'll create an SD card for you. You plug it in the device, and you're good to go. And there's some flags that you can set, like my lunchbox. It has the LCD screen. You just set a flag when you create that, so it sets it all up, and it's very simple to use. So, all right. So I'll go ahead, and I'm going to start my mesh deck. All right, and it says, please enter a command for drone 1. So I think drone 1's on. Let's find out. I'll just do a basic thing. Now, by the way, if I already had this running, when one of those comes up alive and it boots, it sends out an announcement, and it says, you know, something kind of silly like by your command. It doesn't say it in the Cylon voice, it just prints it. And it says, hey, I'm a drone out here and I'm waiting for some commands from you. So, you know, here I can just say, well, all right, I want to run an if config, you know, just to have something. I don't have the wireless adapters plugged in at the moment. I did in the arsenal. I had that all set up. If you want to see it, I can show it to you at some other time. But so, you know, here I've got this guy who doesn't have an internet address, which is obvious because I didn't actually hook it up to anything. But all right, so I can go back over here, and I might want to say, you know, since it's not hooked to anything, I'm going to run an nmap on localhost. And again, I have a lot of stuff in here, so like all those nmap scripts that you might be used to using are on here too. So, you know, you can go run those. All right, so now I can go ahead and just switch over to my other guy and say, hey, what's going on with this guy? And just ran a basic D message, and, you know, here he is. So anyway, there's that. Any questions about this? It's very basic. You know, you can see that it kind of lends itself well to scripting. You can write some scripts that you can execute remotely, capture this stuff. Yes, sir?
I'm wondering if you had remote ownership or installed a malicious app on an Android device,
Mm-hmm.
you could port over some of these Backtrack tools and have your own botnet.
You could. One of the nice things, there's a couple of nice things about the Xbee and ZigBee stuff. One of the things is that it's out of band, right? Even though they're using 2.4 gigahertz, they're using different channels. So like if I pull out my Wi-Fi analyzer, it's not going to say, hey, someone's over here on channel 2, you know, and that's a big advantage. You know, again, if they happen to be using Xbee, if it's a manufacturer, they might be using something like that. Just make sure you pick a different channel, and no one will probably notice. But yeah, you're right. There could be other mechanisms, but for various reasons, you know, this is one possibility. One possibility you could use. Right. Any other questions about that? Right. And just to show you real quick, because I know everyone wants to go home. Right. Here is the Windows tool. It just kills me a little bit inside every time I run Windows. One of my students asked me once, he said, Phil, how come you hate Windows so much? I said, I love Windows. If it weren't for Microsoft, none of us would have jobs. You know, if they weren't pumping out all that vulnerable stuff. I can say that because they didn't sponsor this conference in any way, did they? Right? Okay. So here's that program. It's called XCTU. Oh, it's not going to work because I forgot to tick the box. So it shows up as FTDI, FT232R. Some of you might be familiar with that. FTDI is a little Scottish company. They make all the chips that used to be in like the old Arduinos and stuff. Just go ahead and test it, make sure that I can talk to it. I'm talking to it just fine. And in terms of setting it up, I click on modem configuration. I read the configuration. And now it's telling me, okay, you know, here's the channel, the PAN ID. Again, this is the default 3332. If you want 1337 or something else. And this device has a destination low of 1. And it's my address is the 16-bit low part of the address is 0. All right? Which honestly, if I'm using API mode, doesn't really matter. And again, for the Series 2 in particular, you have to make sure that this says whatever you want. This one just says Xbee Pro. It doesn't have a lot of other options. And I can come here, other things that I can set up. I can set power levels. I can set sleep modes, which are a really good idea if you want to run it on battery. Again, routers, you can't do this, but every other device you can. And you can set up the baud rate. I currently have it set at 57.6. You could go higher. I just kind of left it there because it's fast enough, and I don't want to go too high and start having possible issues about hardware flow control and such. And it's set to enable the API mode. And again, this kind of burned me a little bit. I was working a little late, and I'm like, why isn't it working? I see the little blue light, you know, and I was a little confused. And the answer was because I had it at the default where this was disabled. All right, and it looks like we are just about out of time. I might have time for one more question if anyone has one. If not, feel free to come play with this stuff after we're done. And nothing? All right, awesome. Well, thanks for your attention.